I can safely say that our first keynote speaker has travelled the furthest, because Bob Costanza has come all the way from the Australian National University and is here, and we're really, really pleased you could make it. Bob is the Vice-Chancellor's Chair in Public Policy at the Crawford School of Public Policy. He's also a Senior Fellow at the Stockholm Resilience Centre. Bob is a transdisciplinary researcher. He integrates the study of humans and the rest of nature to address research, policy and management issues at multiple time and space scales. He's co-founder and past president of the International Society for Ecological Economics. And I know we have a large number of students from the Environment Department who see him as really as one of the leaders in ecological economics. So that's fantastic. He was founding editor of the Society's journal, and he currently serves on several editorial boards. He's written 600 scientific papers. I wake up in the morning dreaming about 600 scientific papers, so that's quite incredible. Cited in 20,000 scientific articles, and has been named as one of the ISI's highly cited global researchers. So we really are very lucky that Bob is with us tonight. He's also very passionate about engaging with external stakeholders and also media, and he's written 300 media articles as well through different channels, and we're very lucky to have you. And without further ado, I'd like to hand over to Bob.
So I want to talk about food and other ecosystem services, recognizing that food is a key service of natural ecosystems, of natural capital, and how do we sustainably manage and integrate all of the things that we know about how food is produced, but also how it's consumed and where it's consumed and how it's distributed. And I think all of those issues need to be addressed in a much more integrated way. Who's not heard the term ecosystem services in this audience before? Okay, so you're all familiar with the fact that there was one, okay. Two, wait. What has ecosystem services ever done for me? They are the benefits that people derive from functioning ecosystems. And you've probably heard also then of the Millennium Ecosystem Assessment, which categorized these services into these four broad categories of provisioning, regulating, cultural, and supporting services. Food is a major provisioning service provided by ecosystems, both agro-ecosystems and natural ecosystems, but also in combination with, in an integrated way, with fresh water, wood and fiber, fuel, and the whole list of other ecosystem services of climate regulation, flood regulation, etc. These services all contribute in various ways to human well-being, not just from a consumption of food point of view, but also from a whole range of other constituents of well-being, of security, of health, good social relationships, freedom of choice and action. So there's a much broader set of things that humans need to have a sense of well-being and life satisfaction. There's one thing missing from this diagram, however, and that's the interaction with the other forms of capital assets that are required to have these ecosystem services exist. They don't just flow from natural capital into sustainable well-being. There's a complex interaction between our built capital, our social capital, our human capital, and our natural capital that's required to produce sustainable human well-being. And understanding that interaction, I think, is a core research question. How does that work? How has it worked historically? How can we improve it? We have tended recently to focus much too much, I think, on the built capital asset aspects and the conventional sort of economic production and consumption and GDP, and have left out a lot of things that are not inside the market, that are not exchanged in markets, but that are extremely important in supporting human well-being. 20 years ago, this year, we tried to synthesize all of the work that had been done on the value of these ecosystem services. We identified 17 different services and 16 different biomes, and came up with an estimate, admittedly an underestimate, of the value of all those services, which was still significantly larger than global GDP at the time. So we estimated about $33 trillion a year in 1995 dollars, I think it was. Just to recognize that this is not a trivial, little externality. These are things that contribute to well-being, probably more than all of the things that are in the market. One thing we didn't control was what they put on the cover of the magazine. They said pricing the planet, and really we didn't mean pricing, we meant valuing, and making the distinction between these are things that are not priced and exchanged in markets and shouldn't be, but that are extremely valuable in terms of supporting well-being. More recently, we updated that to see what's happened in this case, not quite 20 years since, from 1997 to 2011. And we estimated that due to land use changes, due to desertification, due to loss of wetlands and coral reefs and other things like that, as we learn more about the value of these services, that in fact they were more valuable than we originally estimated, but we've lost about $20 trillion a year in ecosystem services due to these land use changes that have occurred over that time period. So we have a lot of restoration to do, if you will. And I think agriculture is a big component in that. How do we restore agricultural landscapes? How do we begin to bring the value of those systems and services more into our perception and our decision making? There's a range of uses for this valuation of natural capital and ecosystem services, including just raising awareness and interest. And I think the papers I just mentioned are largely in that vein. But there's also a lot of interest in using them to revise national income and well-being accounts. How do we get beyond just a reliance on GDP? How do we begin to actually measure what well-being is and how to improve it? Specific policy analyses, urban and regional land use planning is certainly something that this project will be involved with. I think this project will be involved with most of these kinds of issues and potential uses for this valuation of ecosystem services. Payment for ecosystem services is one method that's been talked about and used a lot. Could we pay farmers to not just not grow crops, but to do something that actually has a public benefit, like producing clean water, cycling nutrients, etc. Full cost accounting, I think, is another important use. The market is really not telling us the truth about anything that we buy because it's leaving out the impacts of our activities on these ecosystem services. There's a company called True Costs out of the UK, some of you might have heard of, that estimates the external costs by company and finds that there are very few companies actually that are making a social profit. They're calling their external costs profit. So we need to stop doing that. And I think that that could be a major activity that this project can engage in. What are the full costs of agricultural activities? How do we internalize them, or at least use those estimates to better manage our landscapes? The reference for this is a paper that John Foley and others did back in about 2007. Which just shows you, I think, the distinction between the range of services that a natural ecosystem might be producing, what intensive cropland is doing, so it's focusing on crop production, but at the expense of many of these other services, and the kind of system that we might want to move to, one that's more balanced. It might produce a bit less crops, but a broader range of ecosystem services. So how do we build that kind of system? And how do we move from conventional farming to low input farming, organic farming, and what we might call optimally diverse and sustainable farming? If we really take into consideration the full range of products that the land produces, not just conventional crops, not just marketed products. How do we move there? This paper that was done by Ian Bateman as part of the UK National Ecosystem Assessment. And what they did was lay out these 6 different scenarios for the future of the UK out to the year 2060, having to do with a range of ways of managing the environment, regulating the environment, and different kinds of changes, anywhere from the sort of world markets scenario, the kind of business as usual scenario, to the nature at work or green and pleasant land scenario. So different variations on how we manage the landscape into the future. And they looked at this range of ecosystem services. So not all of them, just a subset. Agricultural production, the sort of provisioning services, greenhouse gases, sequestration, carbon sequestration, recreation services, urban green space. And then they also looked at the effects on biodiversity in terms of wild bird species diversity. And for each of those scenarios, then they were able to look at the market values of the agricultural production And then the non-market values of greenhouse gas emissions, recreation, and urban amenities. These are just two for illustration. The bottom line, though, was pretty interesting, that if you focus on just maximizing the market or agricultural values, you get the first column there. Those are larger, but many of the other non-market values are significantly smaller than if you focus on all of the services. And the bottom line, the last row there, shows that maximizing all of the monetary values that they were able to look at created a landscape that was much more valuable, much more productive than one that just focused on the narrow agricultural production. And it didn't have many negative effects on biodiversity. We've also been working recently with the National Australia Bank, and they're part of the Natural Capital Coalition, which is a whole group of financial institutions around the world that have begun to take this idea of natural capital and ecosystem services much more seriously. This is just a screenshot of their website going into what they mean by natural value. And this is the current chair of the NAB. His name is Ken Henry. He used to be the treasurer of Australia. So it's interesting coming from somebody in that position. And I'll let you read some of the quotes here from a speech that he gave recently to this effect. But the bottom line here, I think, is this one piece that says, natural capital is not a footnote in a business plan. It's a core asset on the balance sheet, and that's true for an individual business. It's also true for the nation as a whole. We're working with NAB now, and we had a workshop a couple of weeks ago, along with my colleague Ida Kubashevsky back here. She's also from ANU. NAB is interested in getting natural capital on the books. Why are they interested in that? Partly, if not mainly, for assessing risk. They recognize that farmers that maintain and manage their natural capital more effectively do better in the long run. They may not do better in the short run. They tend to do about as well, but in the long run, they do significantly better. They're better able to resist droughts and other sorts of perturbations. And so they know that if they can assess those behaviors, they can change their loaning patterns. They can give bigger loans at lower interest rates to those farmers that are doing better because they know they're going to be less of a risk in the long run. And I think it's to their credit that they're taking this longer run view and not worrying so much about just what happens in the next quarter or the next year. And I think that's largely what we need to do in order to increase the resilience of farming systems and to give appropriate credit for individuals that do the things that increase resilience. And I think the issue here, and I think what they've recognized too, is that there is a trade-off between efficiency and resilience. A lot of industries, farmers, other economic activities are pushing to get greater and greater efficiency. But by doing that, they're pushing things right up to the edge. And that works fine as long as nothing goes wrong. But if there are perturbations in the system, if there's a shock, then they're going to do less well. On the other hand, you don't want to maximize resilience because that makes the system stagnant. It's too little efficiency. So what we're really looking for is what's the right balance there between efficiency and resilience. Resilience is not a goal in itself. It's really a characteristic of the system that we want to optimize in that sense. And the problem is that it's only something that you can observe kind of in the long term. So how do you get this longer term perspective? And I think that either requires that we look back historically over long periods of times, or we're able to model the system in a way that lets us look into the future more effectively. And to do that properly, I think we need more sophisticated, more integrated kinds of modeling platforms, things that we do, I think these days have the capability of producing. This is just one version that I've been involved in working on, but things that include not just the farming system, but it does include that, but also the whole hydrologic system, the social and human and built capital institutions. That's something that could be applied at fairly small scales, all the way up to regional and even global scales. So what we're doing with NAB is trying to build such an integrated system, a system that both the farmers and the bank could both use, and to better understand how their farm's working, how it might work going forward, how resilient really is the system that they're talking about, and then they can use that to give the appropriate credit for that resilience. Part of that also might involve gamification of that sort of modeling system. How do we make it usable in a way that's much more engaging, and it would have an entertainment value in its own right, but also would have a research component. So we would be able, in these games, to keep track of all of the decisions that players make. And if it's engaging enough, we'll have thousands or tens of thousands or millions of players rather than just a few grad students. We can then use that for research purposes and say, well, how do people understand and value these trade-offs in the modeling system? How do they learn as they play the game more and more often? What can we learn about human behavior itself from that exercise? And at the same time, it will have an educational component as people do learn about what do you mean by ecosystem services. I mean, I don't think most people are going to read even my 600 research papers. They're probably not going to read any of them. But they might play a game that was entertaining enough. So we can it's a different way of communicating. I've been told that humans today spend about 3 billion hours a week playing computer games. So all we need is a small fraction of that time to be spent in a more productive exercise. So, conclusions, ecosystem services, the science of ecosystem services, it's inherently an integrated transdisciplinary science. It's concerned with the way these 4 types of capital interact and contribute to sustainable human well-being. So there's a lot of new research, I think, that needs to be done to sort of get at that question. And inherently transdisciplinary. So I was really happy to see how transdisciplinary this project is. I think it's still relatively rare in academia to have these kinds of transdisciplinary projects. But I think it's what we need to do a lot more of. The process of evaluation of ecosystem services is about quantifying and modeling these interactions and synergies and trade-offs, and improved recognition of the function and value of natural capital in agroecosystems and the food supply and distribution system more broadly, I think is going to be a key factor in developing a sustainable and desirable future. Thank you very much.
We'll just take 2 questions for clarification.
Wondering how you see the critical tensions between sort of optimizing the ecosystem services and feeding people 2050 sort of type scenarios.
Sorry, between ecosystem services and what?
And feeding this global
feeding. Yes. Well, I was going to mention that because I think the numbers that you gave were kind of the business as usual projections on a lot of different things. And I think, as you said, business as usual is not really an option. I think that's a utopian fantasy. What we really need is a major transformation of not only the food system, but I think our whole society. And I think that can reduce the amount of land that we need to feed people. We could redistribute the food that we do produce. We could produce a whole different diet of food. One of the projects we've been working on is ODAS, or Optimally Diverse Ecosystem Services, is what can the ecology produce in an optimal way. We don't want to use grasslands, for growing wheat necessarily. We want some grazing animals. We want some meat production, but we want that to be what's appropriate for the ecological system, what's in the long term, and that's sustainable. So I think changing the incentives is also a major component that would lead to a very different kind of agricultural system, both in terms of the market incentives. So we had a full cost accounting system. We would not be paying more for organic food. We would be paying more for conventionally produced food that had a lot of external environmental effects. And that would change behavior, literally overnight. So there's lots of things we can do, I think, to change and transform the system. And that's maybe one other point, is that we're really not, sometimes things are too resilient. And I think the current agricultural system is, we're kind of addicted to this current system. We're trapped in the way the system is set up. And to get out of that addiction is not going to be necessarily an easy matter. But I think there is a much better way to organize the whole system going forward. And I think that's should be a big part of this project. What does that system look like? Do we really need that much more land? Actually, we can produce per hectare. We could produce a lot more food if we did it in a more hands-on, kind of intensive way than if we do it with big machines. Because big machines are to minimize the labor input, not necessarily to maximize food production. And once we have robots to do everything, then we'll have a lot more time to do gardening.